link that I have sent you second time. The link that I have sent you second time, that is the correct one. The first one was not proper. All right. So, 3:55 સુધી. All right. Last time we did, that was about the force, application of force and its effect. What are the different application of forces? When you apply force, what happens? When we apply force, if a thing is kept on the table, I apply the force, the place is changed, it is displaced. When you apply the force to the moving cycle, you apply, what happens? That it increases its speed. When you apply the force to the shuttlecock that was coming towards you changes its direction and changes its speed. Both is changed. You applied the force in two person applying the force in same direction. What happens? When you apply the force in the same direction, one is applying the force on the box F1 and F2, then the resultant force will be F1 plus F2. Why? Because both are applying the force in the same direction. This is the first case. In the second case, you apply the force in opposite direction and F2. Then if F1 is greater than F2, then the resultant force will be F1 minus F2. And if F2 is greater than F1, then resultant force is F2 minus F1. Okay, I think this I told you last time. These are the things that we used to teach students from the old textbooks. In the new textbooks, there are so many activities are there. The rules, everything is not given that much. The rules and the figures like this was there in the previous course note textbooks. All right. A force can change the state of motion. So, the force can change the state of motion. A stationary ball on the table, you just give a push, the ball moves. A ball is moving, you just put your hand, it will stop moving. So, a moving object is given a force, it moves with a greater speed, and if a moving object is allowed, if you put your hand in between the moving object, its speed will decrease or its speed will become 0. The moving object becomes stationary, right. So, these are the things that you have to remember about force. We hardly think about the actions that are going on around us. If you see, there are so many forces applied in the nature also. It's wonderful things that when we learn about different forces of the universe. We will study it slowly by slowly, and it's very interesting. Okay. So, activity 11.3 says that take a rubber ball and place it on the level surface and tabletop or a concrete floor. Now gently push the ball and the ball will begin to move. Push the ball again while it is still moving. What will happen? Push the ball again. The moving ball will be moved with a greater speed. Now place your palm in front of the moving ball. If the ball is moving, place your palm in front of it. The ball will stop moving. That activity I have already told you. Now you might recall similar situations. For example, while taking a penalty kick in football, now this you know better than me. When the goalkeeper is standing there and the ball comes, the person who is taking a goal, he will hit the ball with the leg, with the foot, and when he hits the ball comes to the goalkeeper and the goalkeeper stops it, right. So the same thing is taking a penalty kick in football, the player applies a force on the ball, and before being hit the ball was at rest. First the ball is on the ground, then there is a signal that you can hit, the player hits the ball, and when it is initially its speed was 0, then its speed increases and the ball moves towards the goal, and suppose the goalkeeper dives or jumps up to save the goal, and by this action the goalkeeper tries to keep a force on the moving ball, and then you can see that the force applied by him can stop or can deflect the ball, saving a goal being scored. Goalkeeper's function is what? He has to stop the ball going to the that goal place. So here also applying a force, the stationary object ball is at 0 speed, then it moves, then it is direction is changed, so many things happens, and these observations suggest that a force applied on an object may change its speed. If the force applied on the object is in direction of its motion, the speed of the object increases. The speed of the force applied in the same direction, the speed increases, and the force applied in the opposite direction, this is the player and this is the goalkeeper. When the ball hits this side, goalkeeper stops it. So it can stop the ball or it can deflect the ball in another direction. So the speed changes. Paheli is curious to know whether application of force can only change the speed of an object. Let us see. If the ball, now see the figure 11.2, activity 11.4. What does that say? 11.4 activity says that when a ball is moving, you just hit the ball is moving, and you put a scale. If you put a scale, the rolling ball will hit the scale and it will change its direction. So what happens actually? The ball is moving, and if you put a scale, this is my scale, the ball hits here and then it goes in another direction. So the speed is changed, the direction is changed. That is what that 11.4 says. Now let us consider some more examples in a game of volleyball. Volleyball also, what happens? The player hit the ball with the palm and hits towards the other team. The other team members send the ball to again to this side. So thus the ball is returned to the other side of the court by pushing or smashing it, right. In cricket also, batsman plays his or her shot by applying a force on the ball with the bat. The bowler throws the ball, the batsman hits the ball, it changes direction, it changes speed, okay, So, all these activities that we have done, either ball or cycle or applying force or changing the direction or changing the position, stationary becomes moving, moving becomes stationary, the rate of the speed increases, decreases. Only the one thing that is most important to remember is the force. All these actions around us, all these actions are because of the force. Force is a change in either of the speed, direction, both describes in the state of motion, change in the states of motion, and all this is because of the force. So, force can change the speed, force can change the direction, the force can change the state. Moving objects become stationary, stationary object becomes moving. Now, does that mean that only this much is the effect of force? Let us find out. Now, see what I am going to do. This is one paper, I am applying a force on it. What happened? The shape is changed. This is also the effect of force. So, what are the effects of force? One more effect that you have seen. If you take a plastic ball, sorry, if you take a plastic ball and press it with your both the palm, what will happen? It will become D shape. If you take a, suppose, balloon, inflated balloon, and then press it, what will happen? Either it will suffer the shape or it will burst if you apply more force. So, that is the thing, that in some situations applying force is not only change the speed and state and other things, direction. Up till now we have seen change the state, change the speed and change the direction. Now, one more thing we are adding it is change of shape. What are the effects of force when you apply force? You get a lump of dough on a plate. If you put water into the dough and you see the dough becomes, you can change the shape. Take a small dough and you can make it a round ball. You can change its shape. So, all these things, applying a force by hand, you change its shape. You can't change in the state of motion. The second example, spring fixed to the seat of the bicycle. If nobody is sitting on the bicycle, the seat becomes at rest. Somebody is sitting, the seat will go down. A rubber band suspended from a hook or nail on a wall. When you suspend a rubber band and you stretch it, the length of the rubber band increases. And next, a plastic or metal scale placed between two bricks. If two bricks are there and you put a scale in between, and you can see that the shape of the scale becomes different, the shape changes, it becomes tilted downward, right? All right. So, these are all the example of change in shape. Now, we come to what are different activities we did up till now and what are the conclusion from it. The first conclusion, that when the force of an object, when the force is applied on the object, the different effects is, it may make an object move from rest. The object move from resting position, stationary position to rest, no, to moving. may change the speed of an object if it is moving. Your friend is riding a bicycle, and if you push from back side, the speed will increase or decrease? It will increase. It may change the direction of motion of an object. What happens when you play badminton with your friend? The shuttlecock that is coming towards you, you hit back, the direction is changed. Your friend again hits towards you, when it comes to your side, again you hit, the direction is changed. May change the direction, may change the speed, may change the state, may bring about a change in the shape. I showed you just now, you can change the shape. You may cause some or all of these effects. Now, it is not necessary that all the effects you can see in objects. You can see one effect when you apply force. Now, is it possible that the object moves by itself? No. Objects are non-living things. They cannot move. They cannot be changing. They can't change their place. They can't walk. They can't displace by themselves. You have to apply force. So, here you have one question to write in your CW. What are the different effects of forces? When you apply force, first stationary object becomes moving. Moving object becomes stationary. So, state is changed first. Second, speed changes, either increase or decrease. Third, the shape changes, right. Fourth, it may change the direction. The object may change the direction. So, please write all these effects and write one example of it. What are the different effects of force on an object? All right. So, that is all for question. Now, we move to the another topic, contact forces. What are contact forces? I told you the subject is so interesting. Now, do you have any jadoo with you, that even if you do not touch the object can move? Can we do that? No, we cannot do that. If I want to sit on a chair, I have to bring it to where I want to sit. If I want to open the door, I have to go there and touch, and I can open the door, right. So, all these things where contact is very important. Contact forces, that there are so many examples of contact force in our life, in our body. What are the different examples? Can you see the contact force? The contraction and relaxation of lungs, the contraction and relaxation of heart, right. These are the forces that applied by the muscles. The digestion takes place by the contraction. In the alimentary canal, the food is pushed and pushed. Food is mixed with the motion of the alimentary canal. So, that is because of the muscular force. The first example of contact force is muscular force. Anything to be done by a person, it applies the muscular force. Now there are so many things is getting done by animals. They also use their muscular force. Have you seen this picture in reality? 11.9. So common picture in Indian village. Such a big load is pulled by a bullock cart. Such a difficult task, such a heavy load is pulled by bullock cart, and this is also done by the muscles of bullock or cow. Look at here, right? Even we have seen the donkeys carrying so much load. Animals are also applying force. So force is important. That first thing we have seen is when you apply force, when you apply muscular force, the things are done. Second thing that we see in nature, very common experience of us, that we roll a ball on the ground. The ball on a smooth surface, you give a push. Very slowly, if you give a push, the ball will roll it, and slowly its speed decreases and it comes to rest. Why? The speed becomes 0. Why? Because it is the force that is applied by the friction. This is the surface. We will talk about the smooth surface. And this is, suppose, my ball which is rolling on the ground, and it is moving. Initially when you apply force, it moves, and a time comes when the ball becomes stationary. What happens that the ball becomes stationary? Because the surface, this movement, that is external force applied by muscles, and a force applied by surface, in this direction. The surface applies force on the opposite direction, and this force hinders the movement of the ball. It stops the ball from moving until when this force is more, the ball moves. When this force becomes 0, that means the friction of the surface, this force is known as friction of the surface, that applied in the opposite direction of the force applied, muscle force applied, and this stops the ball at one point, right? Okay. So in contact force, we have done that force applied on the object, muscular, the force applied on the object. In contact, we are doing contact forces. In contact forces, the force applied, first one is muscular force, and the second they have given is of friction, gharshan. When we walk also, when we run, the force is applied from the surface, and that force hinders or stops our moving, and this force is known as friction. And this frictional force is responsible for stopping the ball, making the speed of ball 0. The gradually decrease in the speed of moving ball is because of the frictional force. So, here you have a second question, write it down. What are contact forces? Contact forces are the forces in which the object and the force are in contact with each other. They touch each other. So, it is known as contact force, and when the object and force are not in contact, it is non-contact forces. It is very known to us, non-contact force, but we don't realize it. We will do it next time. Today we have done contact force, muscular force. Okay, we can complete non-contact force also. It is very simple. The force that is due to the magnet. Have you seen when two magnets are brought together, either they attract or they repel. They attract or they repel. If you put 3 pencils, rolling pencils, round one, and on it if you put a bar magnet, and here if you put 3 pencils and you bring another magnet near it, or if you bring another magnet near it, if both are of north direction, they will repel, and this magnet will move towards this side, and that is why the pencil will also change its state. It will move. All the 3 pencils are rolling pencils, so it will roll this side. And if you put here, instead of north direction, you take another magnet, and here north south direction, this will attract each other and it will move towards this side. The magnet will move, and so the pencil will also move, and you can obviously see those 3 pencils moving. Very interesting. If we were in the class, I would have shown you, but we are virtually together. So, that is the example of non-contact force. So, after contact force, it is first non-contact force, that is of, first one is magnetic force. Second is gravitational force. Now, gravitational force also, you know, if I throw this, it will come down. Why it goes down? If a chalk slips from my hand, it goes down. I am not doing anything. I am not doing anything. I just hold it, and if it slips from my hand, it goes down. I am not throwing it down. Even if I put it up, it will come down. Why? That is gravitational, gravity. There is a big magnet inside the geographic north and south pole magnet. You have done it in your previous classes, and that non-contact force, again a gravitational force, that is responsible for the movement of object. The third is electrostatic force. Non-contact, first, second and third is electrostatic force. Now, if you take a plastic comb, you rub it in a hair and put a paper bits on the table and try to see that paper bits are attracted towards the comb. Why it happens? What is the reason? The comb, which is charged, it is all positive charges, settle on the surface, and the paper bits, if you put here, these paper bits are attracted to these charged particles. Here one example is given. If you take a straw and cut it from the middle, and one end of the straw, if you one of the straw, two parts that we have cut, if you take the one cut part and hang it like this, and the second part, if you rub it on a glass and you put it near, the straw will come down. And this is also just the same reason as electrostatic force. So, electrostatic force is the third force that is responsible for attraction and repulsion. So, here we have completed non-contact force. Write the third question, full short note, non-contact forces, contact forces. Give the example and activity which is given in your book, giving each of it example: muscular force, frictional force, non-contact force, magnetic force, gravitational force, and electrostatic force. For each you have to write one example or the activity which is given. No need to draw the figure. That is all for today. Thank you so much for watching, but write those three. I think I have given you short note. It is not the short answers. The answer will be of at least 2 pages. So, complete it. Next time I will take pressure. That is all for today.